Good morning, students. Today we are going to see the next subtopic. Okay, which chapter we are in now? Periodic classification. We have studied about two people. No, who are those? Dobereiner and Newlands. Dobereiner has given us the triad, and Newland has given the law of octaves. Right? Okay. Now today we will see the next person who worked for this. Okay. He is Dmitri Ivanovich Mendeleev. See here, Dmitri Ivanovich Mendeleev. As usual, we will see a small introduction about Mendeleev and then we will see his work. Okay. So Dmitri Ivanovich Mendeleev, he was born on 8th March 1834. Okay, 8th March 1834 and died on 2nd February 1907. Maybe 73 years old. No? Okay. When he was dead. He was a Russian chemist. Okay. He was a Russian chemist. When I read about Mendeleev, it was very interesting to read, okay, the facts about Mendeleev. So here they have given that both his father and mother, they are good, and they had how many children, 17 children, and he is the 17th one. Usually in the olden days, they will give birth to many children, but most of the children, they will die in between. Right, no? Only few will be left out. Maybe 9 to 10 children are left out. And in that 17th child, who? Mendeleev. So, usually the youngest one will be treated like a baby. No? So, here also the same thing happened. And mother, she loved him a lot and he also loved his mother a lot. At the age of 13, he lost his father. Okay? And many problems arise, and he was an Orthodox Christian. So they are Orthodox Christians means they will be knowing. They will be how they are. You read about, okay, Orthodox Christians, how they will be. Okay. Now here he has given a statement that about his mother. She instructed with examples and corrected with love. Wow, great, no? She instructed with examples and corrected with love. Most of the things he has learned from his mother only. Lost his father, and mother was also having a glass factory, and that also got some loss in that. Okay, and so many problems were there in his family. And finally, we are going to see what he did. Okay, for our periodic table. Now at present we are having a long-term periodic table. So he did a lot. His work was considered and it was, he proved many things, and he is called as the father of periodic table. Okay. So his work should be more. Then only they will give that father the title. No, otherwise it is difficult. So he is called the father of periodic table. Shall we see? And you can also read about his family, his 2 wives, and then about his children. They are also very famous later after his death. Now we will see what he did for our modern periodic table. Okay. First we will see his work, and then that was a base for today's modern periodic table. Shall we go? Okay. At his time, 63 elements were there. Okay. How many elements were there? When Newland was doing that, 56 I said. When Dobereiner was doing, it was 30. But at the time of Mendeleev, 63 elements were discovered. Okay. He tried to, this is very important, he tried to correlate the atomic masses with their physical and chemical properties. This is very important. I told you that for Dobereiner, Newland and for Mendeleev, which is the base? Atomic mass. They started working keeping the atomic mass in their mind. Okay, later it is different. Now it is atomic number. So he tried to correlate the atomic masses with their physical and chemical properties. And mainly on on the behavior of oxides and hydrides. Chemical properties also mainly on the behavior of oxides and hydrides. Why he selected oxides and hydrides, you know? They are highly reactive and they can make many compounds. Okay, so many compounds are formed based on that. So they highly has taken oxides and hydrides. And he has given a statement that which law? Mendeleev's law. It is called as Mendeleev's law. According to Mendeleev's law, the properties of elements are the periodic function of their atomic masses. The properties of elements are the periodic function of their atomic masses. It is very important. Properties of elements are the periodic function of their atomic masses. He also termed this one periodicity. What is periodicity? Newland said that after arranging all the elements, the first element and the eighth element, they have similar properties. So here also some similarity he was able to find out, and he said that after a definite gap, it is not that after 7th, after 8th and all. Periodicity means, for example, full moon day we used to count. Now how we used to count? New moon, full moon and all. After certain period. No? Same way here also he said that the repetition of properties are seen after a definite gap. That term is called as periodicity. Okay. So first an introduction about Mendeleev. Then when we start with his law, 63 elements were known at that time. He tried to correlate the atomic masses with their physical or chemical properties. Chemical properties also mainly on oxides and hydrides. Why he selected oxides and hydrides is an important question. It's very reactive and it can make many compounds. And this is Mendeleev's law. The properties of elements are the periodic function of their atomic masses. And also, what is periodicity? If the similarities are seen after a certain period, then that is called as periodicity. So, repetition of similar properties after a definite gap is called as periodicity. Shall we see how he placed this periodic table? Okay. So, those two people who Dobereiner and Newland, they have just given with the elements which were discovered at that time. But now he got 63 elements. So I said that he was a great chemist. Okay. He worked in many schools, many colleges, and he is having a good knowledge at that time when he found periodic table. Okay. So what he did now, he wrote the elements, all the 63 elements, and he pasted it on the wall. Then he got an idea, why can't we make it in a tabular form so that it will be easy to study the properties. Okay. If he is the father of modern periodic table, how much he would have worked, that is very important. Okay. So father of periodic table. What he did now, he divided them into groups and periods. This is very important. Vertical columns are called as groups. So this is called as groups. See how many groups are there? 1, 2, 3, 4, 5, 6, 7, 8. So the vertical columns are called as groups. Okay, vertical columns are called as groups. How many groups are there? 8 groups. 1, 2, 3, 4, 5, 6, 7, 8. He has not, you should not write 1, 2 like that. It should be in this Roman numericals only. How he has given, no? Same way we should give. 1, 2, 3, 4 like that. 8. And while doing that, no, first 7, 1, 2, 3, 4, 5, 6, 7, he has not made it into subgroups. But for, see here, he has made it into subgroups for first 1, 2, 7. Subgroups are there. It was divided into A and B. But the 8th one is left like that. That is transition series will be there. And in the 8th group, no, first, second and third are left out. 4, 5, 6. These 3 have triad. This term already who has given, Doverina has given one term called as triad. No? So this is also 3 elements are placed in one column. So it is called as triads. So it is very important. Vertical columns are called as groups. So keep this in mind. To make it very easy, what we will do now? Very good you put here. Very good. Vertical columns are called as groups. So the other one is periods. Horizontal rows are called as periods. See here, this is horizontal. Horizontal rows are called as periods. See how many periods are there? 6 periods are there. 1, 2, 3, 4, 5, 6. You don't want to by heart, but you should know what is there. So I have drawn this. You don't want to study this. You should just observe and study what is given in this. Okay. So vertical columns are called as groups. Vertical columns means like this. Vertical columns are called as groups. How many groups? 8 groups. And in the first 7, he has divided into 2 subgroups. A, B, like that. In the 8th one, there is no subgroups, but that is called as transition series. Okay. It is called as transition series. And in the 4th, 5th and the 6th period, 4th, 5th and the 6th period, 3 elements will come. So it is called as triads. So total how many will be there? 9 will be there. So based on what he has divided, first you see atomic mass. I am repeating this again and again because it is very important. It is arranged based on atomic mass. So vertical columns are called as groups that we have studied. Now the horizontal rows are called as periods. I told you this is 1, 2, 3, 4, 5, 6. So in the 6th no, first 3 there is no division. But 4th, 5th and 6th no, he divided it into 2 series. First series, second series. See, first series, second series. First series, second series. Like this he divided. Okay. And I also told you that it is main thing he divided based on the behavior of oxides and hydrides. Right. So oxides, hydrides. Oxides when he is giving, know how he has given, see. R is the name of the element. Whichever element you are taking, no, that will come. See for example H. So in the place of R, who will come? H will come and the formula will be H2O when it combines with oxygen. Lithium when it combines with oxygen, Li, how? 2, no? Okay. So the same formula will be given for all the elements which are coming below this. Okay. Here RO, so BeO, CaO, ZnO, like that. It will be combined. In the place of R, you should put the element. Okay, that is very important. So how he has given, see R2O, then R2O3, leave one gap and I tell you R2O, R2O3, R2O5, R2O7 to keep it in memory. The other next one you see RO, RO2, RO3, RO4. Okay, so oxygen it will combine in this way. See for example aluminium Al2O3. No, so in the place of R, if you put this no B2O3 like that, properties are showing some similarity. Hydrides if you see RH, RH2, RH3, RH4. Mainly it is like 1, 2, 3, 4. Valency we have studied, no? We will be studying in the modern periodic table. At that time I will explain it. Now H, H2, H3, H4. Then again it is decreasing. H3, H2, H. Okay, this is how hydrides. For example, for Li will be H, which hydrogen. K will be with H. Okay, so like that it combines. Now, this is atomic number or mass number. Mass number. Okay, weight 1.008. So 6.939. The next one is 9.012. Then 10.81. Like that it goes on increasing. But here you check once. Iron, cobalt and nickel when he has put now 55.85, 58.93 and 58.71. Actually 58.71 should come first, no? But he has arranged like this. That will come under limitations. Okay. So these 3 are called as triads and how many elements are there? 9 elements. Okay. So this is how arranged the elements. In this, very important thing is some gaps were, I have not filled the whole thing. It is not necessary, so I have not filled. But when you check in your textbook, there will be some gaps in between. See here, first series will come this side, left hand side, and the second series will come in the right hand side. So left hand side, right hand side, left hand side, right hand side. Sometimes it interchanges also, right hand side and left side. Here the main thing what we want to look is many gaps were also left out. Okay, and he was very confident and he said, he predicted that in future many more elements will be discovered and they will come and fix in this place. Great, no? Predicting as well as confidently telling that new elements also will be discovered and they will fix in that particular place. It is very difficult. I can't tell that something will be discovered, that maybe he would have told that something will be discovered. So, but giving a place in the periodic table is very difficult. So here what he did? He has given a place and he said, and he predicted that new elements will be discovered. So many gaps for undiscovered elements. He has given gap for undiscovered elements. And here if you see, noble gases are not seen. And I told you that noble gases were discovered later. Rayleigh and Ramsay, they discovered it. Helium, argon, krypton, xenon, each one is having an interesting story. Read it, okay? So noble gases were discovered later. And what they did know in the modern periodic table, without disturbing this, they are unreactive. So they have been given a place, zero group. Okay? Separate group. So that's no problem. It was discovered later. So this is very important. See, boron, silicon, aluminium, already it was found. Boron, silicon, germanium. See, those who are in Sanskrit now, they will be knowing about Eka. What is Eka? Means one. Here, he is not an Indian, but he has given a term like Eka boron, Eka silicon, Eka aluminium. See, he is a scholar now, he has read many other things also to find out how it is, how to get this term. So, I shall come here now. Eka boron means what? Boron is already there. And next to boron, what other element will be discovered and it is named as Eka boron. He has not given a particular name for that. Okay, a new element will be discovered and that name he has given it as Eka boron. Silicon also. The first one is silicon. Next to silicon, some other element is going to be discovered and that is named as Eka silicon. Eka aluminium. Eka boron, Eka silicon, Eka aluminium are the three terms. He has three elements he has discovered. But later, when it was discovered, no, they have named it as scandium, germanium and gallium. Scandium, germanium and gallium. Okay, you should not mismatch it. Should be very clear. Boron, silicon, germanium. Boron, silicon, aluminium. Boron, silicon, aluminium, and later it is named as scandium, germanium, gallium. Okay, scandium, germanium and gallium. Scandium, germanium and gallium. This is about Mendeleev's periodic table. Shall we see the achievements and the limitations? Okay. After seeing this, as I told you, he is the father of periodic table because he is the one who divided it into groups and periods. In our modern periodic table also we have groups and periods, but little systematic. Here what has happened? He has divided on the basis of oxides and hydrides, and so that is the reason he has given first series, second series, and here oxides means some formula. If it is hydrogen, if it combines with hydrogen, some formula, and he has also given transition series and named it as triads. 9 elements were there. Okay, and some were not discovered at that time, but he predicted that some other elements also will be discovered, and he has given Eka boron, Eka silicon, Eka aluminium. So you keep this like this: BSA, boron, silicon, aluminium. Eka boron, Eka silicon, Eka aluminium. And the scandium, germanium, SGEGA. Like this, you keep the mnemonic in your mind. Okay, scandium, germanium, and gallium. It may be asked in one more question. Eka boron is called what? Eka silicon what? Eka aluminium what? Okay, so this is very important. Come, we will see the achievements and limitations of Mendeleev.